Okay, ladies and gents, next up, number 22, 23, 24, and 25. Number 22 is giving us a circuit, and we got to read this carefully. It says we are connected in series. That's going to be crucial. All right, so let's make sure that we are thinking about series circuits, and we can even draw a little picture of this. All right, we got our battery, and then we have 4 resistors. 1, 2, 3, 4. All right, and this is 24 volts. This is 3 ohms, 3, 3, 3 ohms, 3 ohms, 3 ohms. Cool. So, and in our second circuit, all right, so this is A, and our next one is circuit B. Circuit B has 2 resistors connected in series. So here's our circuit B, 24 volts, 3 ohms, 3 ohms. Okay, now this is one of those questions where the wording is designed to trick you. All right, so it talks about the total potential drop and total potential drop across each one. When it talks about potential drop deals with voltage. Okay? Potential drop is another word for voltage. Potential drop equals voltage. So if potential drop equals voltage, well, the total voltage of A is 24. The total voltage of B, this was B is 24. So it looks like those are the same. Right? So file that little bit of vocab in your memory that potential drop equals voltage, and then that question is a piece of cake. Next question is a calculation. 23 is asking us to find total energy dissipated in a resistor in 10 seconds. All right, and this one is a nice straightforward formula. If you look up, you'll notice that electrical energy is denoted by a W on your reference table, and that the formula that you want to use is equals I squared R T, okay, because here's T, here's R, here's I, and here's all of those put together. So you just run that. You have 0.5 amps squared, and your resistance is 4 ohms, and your time is 10 seconds. And I don't even have my calculator right now, but I know this is 0.25 times 40, and that is going to be 10 joules. Boom. Number 24 is asking us to find what happens when you move wire through a magnetic field. Right? And again, this is something we did not talk about very often. But whenever you move wire through a magnetic field, that gives you electricity. So things here that have to do with electricity. All right? It is not talking about temperature. All right? Resistivity is a property of the materials, and this is the potential difference. This is how you get a current. Right? And that is a pen that isn't working. In number 25, it's asking about a pulse transferring what when you move a pulse through a spring. When we were doing waves in class, when you shake the spring, you're not moving mass. The person who's shaking the spring on one end doesn't end up with any more or any less spring in their hand before or after they shake it. All right? We talked about waves are a way of transferring energy. A pulse is a single wave. All waves and pulses transfer energy and energy only.